let's kick this off then. So good morning, everyone, and to everyone who is joining us. My name is Matt Klassen, and I'm the Executive Director of TMA BlueTech. And want to welcome everyone to this iteration of our monthly BlueTech Global Connect webinar. Today, our topic is going to be building a sustainable future for our ports and harbors. And we have arranged quite a fantastic panel today. Our moderator for today's discussion is going to be Paula Sylvia. She is the Program Director for the Aquaculture and Blue Technology program at the Port of San Diego. Your presenting companies are going to be Emily Hicks with FredSense and Trevor Ludwig from Ecospheres, and Mayor Besnor with EcoConcrete. Before I hand this over to Paula, and for those who don't know, TMA BlueTech is a San Diego, California-based nonprofit that promotes sustainable science-based ocean and water industries. Our tagline is promoting blue tech and blue jobs, and we are based on the triple helix model, which brings together academia, policy, and industry to further the cause of sustainable blue tech. Our three areas of focus are economic development, business ecosystem development, and national and international outreach. So our 14th annual Blue Tech Week conference will be held in person again this year from November 14th to the 18th. This conference is one of the world's premier Blue Tech events where we bring together a fascinating array of high-level professionals from around the world to talk about the state of Blue Tech through the lens of academia, industry, and policy. So we'll put a link to the chat box for those who want to reference Blue Tech Week for more information. Starting on Monday, we will begin to actively promote Blue Tech Week. So we have the agenda is looking really, really good this year, and we're excited to start to put together the panelists for a range of different sectors and discussion points. So plan on attending if you can and telling your colleagues. Also, if you would like to follow TMA on LinkedIn, TMA on LinkedIn, we'll put that in the chat box as well. Just for everyone's information, we're recording the webinar. So for those of you who would like to reference this webinar at a later time, we will post it on our YouTube channel, and we will also include our YouTube channel URL in this in the chat box here. So a few housekeeping items before I hand the ball over to Paula. Our presenters will have 10 minutes each to present. At the 9-minute mark, I will give a signal that 1 minute is remaining. Other than this, Paula will facilitate the discussion, especially the Q&A at the end, where we should have about 30 minutes for that discussion. If you would like to ask a question, just write it out in the chat box and we'll make sure it gets posted or asked during the Q&A. So with that, I would like to hand the table over to Paula from the Port of San Diego. Paula, the floor is yours.
Thank you, Matt and Danielle, and thank you, TMA, for hosting such awesome webinars every month. We really enjoy them, and we're super pleased to be part of this month's webinar and hopefully many more in the future. So thank you, and thank you so much to 3 of our fantastic portfolio companies for being here to present your fantastic technologies. So I'll just start with a quick background on the program at the port. The Aquaculture and Blue Technology program is a relatively new program at the port. It's nearly 7 years old and was created by the port to look at environmental and economic opportunities in the aquaculture and blue tech space, and ideally look at opportunities for diversifying the port's business portfolio to include new sustainable businesses. So underneath that program, we created what we call a Blue Economy Incubator, which allows the port to partner with early stage companies in those spaces and primarily facilitate pilot projects. So really our core value proposition in this incubator space, we're not a traditional incubator that might offer office space or mentorship or other services, but instead our services are based on pilot project facilitation. So we offer some type of port-based asset, whether that be a land or water rights or a lease to launch a pilot. We actually, offer permitting and entitlement services, which are quite, important, and especially in the state of California, since it's difficult to permit new things and even old things. And then, in many cases, we offer market access, marketing and communication services, and then also in most cases funding. So we're really looking at figuring out how to, hopefully what you'll hear from these companies today is, how they're able to demonstrate their technology in a real world port environment. Ideally, make a good use and case study at the port, so that sets up folks for commercialization or regulatory approvals in some ways. So I don't want to take it away from the companies themselves. I'd like to just get right into it, and then we can answer Q&A when we're at the end. So the first presenter today is going to be Emily Hicks from our FredSense. Emily's the president and co-founder of FredSense, and we're looking forward to your presentation, Emily.
Awesome, wonderful. Well, thank you so much for having me. I don't seem able to share my screen.
Danielle, can you help with that?
Oh, there we go. It seems like it's fixed now. Perfect. Is everyone able to see that? Wonderful.
Yes, ma'am.
Great. Well, thank you so much for having me today. It's my pleasure to chat with you a little bit more about FredSense. So at FredSense, essentially, our goal is to create really great portable instrumentation for doing water quality analysis anywhere. So being able to take a unit into the field and be able to measure some kind of parameter. And so our goal is to make this quick, make this easy, and make this something that provides really good quality data. And so we essentially are a platform where we measure different parameters, and we work with different water quality specialists to be able to provide them this data. And so where the company really got started was from some work a number of years ago now at the International Genetically Engineered Machines Competition. And so this is a big genetic engineering competition run out of MIT every year for groups around the world that use biology, so engineer an organism or some kind of biological system to do something interesting. And so back when I was a student at the University of Calgary, we were competing in the iGEM competition. And what we were really focused on, being from Calgary, Alberta, was could we create a bacteria, engineer it to be able to detect contaminants in oil sands tailings ponds, and then be able to turn those into value-added compounds. And so we did really well at the competition. We won a bunch of awards, and afterwards kind of realized that this idea that we had actually had applicability far outside of just oil sands tailings ponds, and specifically this concept of engineering bacteria to be able to detect different parameters in water was actually really interesting. And the more we dived into it, the more oil sands tailings ponds was not actually a huge market opportunity, mostly because telling people better, faster, cheaper about problems that they don't really want to have was not a super compelling value proposition. But what we really realized was that actually being able to measure different contaminants in a field environment was really tricky. And while we have really great technology for a lot of physical parameters, things like pH, temperature, turbidity, there aren't a lot of good field kits for operators to be able to detect things like heavy metals, things like specific small molecules, pesticides, emerging contaminants. Across most industries, people were still using the analytical lab, which means that you have to package up a sample, ship it off, and really depending on where you're located and what kind of lab services are available, you could be waiting sometimes several weeks to get data back, which makes it really difficult to make decisions about things. It makes it really difficult to get timely data, streamline remediation processes, all sorts of things. And so what we really determined was that using bacteria, we could create some hardware and software systems around that to enable this field measurement. And what's really interesting about bacteria is that they've evolved over many, many, many years to be able to detect all sorts of different contaminants that they have to interact or respond to. And so we spent several years creating some different hardware and software systems around this to allow us to be able to use these sensors in a field environment. And so the FredSense model today is based on a cartridge. So we make small little cartridge units that you add a water sample into. You plug it into one of our FredSense devices. It does an incubation period, and in about an hour, it has data ready that it can transmit to you about what kind of the concentration of a specific parameter. And so the company started initially with arsenic analysis. That was the first sensor that we built and is commercial now. And this was really focused around groundwater and around utilities in the southern US. And we realized that there's arsenic naturally occurring in many, many groundwater systems, across all sorts of different countries, and lots of places have active remediation, but they really don't have ways to actually measure that in real time. They're often relying on analytical lab results, so they get a snapshot of what arsenic levels looked like maybe 2-3 weeks ago. And that's not terribly efficient when you're trying to streamline a process and make sure that you're always remediating within an appreciative amount. And so our first sensor was called Fred Arsenic. So we used a bacteria that we engineered to be able to detect arsenic, and we were able to get some really great results. And so this was some data that we collected with a partner utility in the southern US, where we were looking at measuring a series of different groundwater wells across their system using the Fred Arsenic system, and then comparing it to both a process lab that they had on site, as well as a compliance lab that they were using to do their quarterly sampling. And so we're able to see some pretty good results where we generally were able to come within 2 parts per billion or less of what the analytical lab was seeing. And this was really helpful for them because this allowed them to use our system on site to be able to actually streamline their remediation process without having to always rely on the analytical lab each time. And so as we kind of developed things further, we had a really interesting project with a government group in Canada, and we were working with them on developing a sensor for an additional heavy metal. But they also had a request to develop a sensor for acidity. And this was a really interesting challenge because bacteria aren't really very equipped to develop sensors for acidity. That's not really a parameter that they can detect. And so we were looking at other ways to build in a solution for this that could work with our existing platform. And so this led us down a path of using a lot of the skills that we developed in terms of creating field-enabled hardware and creating robust solutions and some liquid handling components. And we started developing more of a colorimetric platform. And so we did some work creating an acidity and an iron sensor for this government group. And we were able to get some really great results. And with a field kit that we created that had very little input from the user. So this was one of the early prototypes in yellow. And you can see it has 2 little sample bottles on it that a user would essentially fill up with a water sample, plug into the unit, hit go, and it would run an acidity and an iron measurement on it. And so this was really exciting for us and kind of led us down a bit of a different pathway because we realized that there was a lot of different parameters that we could build on this colorimetric system and really provide this easy to use system in the field, building on a lot of our core hardware that would allow users to be able to measure some of these things in real time. And so that led us to get more involved in things like stormwater and ports and looking at what kind of parameters might we be able to measure after a storm event, for example. And so this was kind of the development of a bit of a sister platform for us at FredSense, which has been really exciting. And so this is really what's led us to the work that we're doing with the Port of San Diego, which we're really, really excited about. And so we've started work with them on developing a 5-in-1 solution for measuring some different heavy metals. And so we're focused on the detection of copper, nickel, aluminum, lead, and zinc, and essentially creating a portable unit that allows a user to be able to measure these by just taking a water sample, plugging it into the unit, and we then have a cartridge-based system that's able to have the reagents stored in it for this test and able to run these different parameters and be able to report data on this. And so this has been really exciting for us because it's a little bit different than what we normally do, but fits into a lot of the hardware solutions that we're using. And has allowed us to get a lot better at things like liquid handling and automation, which in turn is allowing us to push forward some of the work on our biosensor platform, where those were really holdups in some of the development that we were looking at, especially as we look to the future to more automated, potentially even inline systems for some of the groundwater work that we're doing. So some of the project objectives that we have is really just to demonstrate accuracy of these tests. We're doing some work in the lab setting was what we initially started with, then starting to build some of these field tests, and we're planning to do some field pilot work with the port. And eventually the goal is really to have commercial delivery of the system. So we're hoping that through doing some comparison analysis of our test with the analytical lab with real world samples in a real world setting provided by the port, we'll be able to show the use case that the system is easy to use. We're able to get high quality data. And hopefully this will lead to eventual commercial delivery of the system. And our ultimate goal would be able to get some kind of regulatory approval on this down the road. So really the goal behind FredSense though is to create a real platform. So outside of some of the stuff we've been doing with the port, outside of our arsenic work, we have a suite of other sensors that we've been working on that are either at pilot phase. Some of them are commercial and some of them are earlier stage, but we've been doing some interesting work on COVID-19 analysis and wastewater. And we have some interesting projects with some partners looking at emerging contaminants such as PFAS selenium, and some other heavy metals. And we have customers today across Canada and the US, but also doing some interesting work in the Middle East as well as APAC. So I'll leave things there. I hope that that gave you a little bit of information about FredSense, and I'm happy to answer any questions that you have or connect with you in the future. So thank you so very much.
Thank you so much, Emily. That was fantastic. And I think just so everybody knows, we're going to hold questions till after the presenters speak, and you can put your questions in the chat and we can facilitate a discussion at the end. So thank you so much, Emily. That was fantastic. We're going to move on to our next speaker, Trevor Ludwig from Ecospheres. Trevor is the program manager at Ecospheres and heavily involved in our pilot at the Port of San Diego. So here you go, Trevor.
Awesome. Thanks, Paula. Yeah, like Paula just mentioned, my name is Trevor Ludwig. I am a project development manager here at Ecospheres. Let me see if I can move this. There we go. At Ecospheres. And Ecospheres is a clean tech company based out of Orlando, Florida. We have a vision of a world where every human being should have access to clean water, clean food, and clean air. And we're going to get to that by ushering in the net zero future of the environmental remediation industry. The chemicals that we're looking at right now of treating are mainly PCBs and dioxins, and we're also starting to evaluate different technologies for the new and emerging compounds like 1,4-dioxane in groundwater, along with the PFOS and PFOAs. So Ecospheres, we really picked PCBs and dioxins because it's a well-known problem throughout the US. In 2016, the federal EPA actually did a fish tissue sample of many of the nation's waterways, and they discovered that 94% of these waterways, in either some capacity of passive sampling in the pore water, sediments, or in the fish tissues themselves, contain some levels of PCBs or dioxins. We saw this as a really big issue as these compounds have been outlawed for the last 40 years, and they're still persisting in the environment today with methods like capping, with either just a normal sand cap or like a granulated activated carbon or a dredging, are continuing to show less and less ability to close and eliminate these toxins in the environment altogether. And not only are they showing less and less likelihood of closing and actually dealing with these methods, but they're also inadequate in a sense of there's impacts to the local communities from greenhouse gases that are emitted through these processes, but also they're intrusive to the environment and destructive of the local habitat area. This is why we've partnered up with NASA to develop and gain the exclusive license for our Spears technology. To give you a little backstory on the technology itself, this brilliant scientist in the top left corner is Dr. Jackie Quinn. Jackie Quinn is a patent and just a researcher at NASA that has come up with some of the most widely used NASA patents, like the EZVI technology. In 2012, she was doing a study of microplastics in the environment and saw that there was PCBs and dioxins found actually within the microplastics floating throughout the ocean. She started to theorize that the plastic was a really good absorptive material for these common contaminants that are found throughout most of the sediments layers in the US, but also around the world as well. So she went to UCF in 2014 and partnered up with Dr. Philip Maloney here in the bottom left corner. Over the next 8 years, her and Dr. Maloney have utilized this technology to scale to what it is now. Dr. Maloney is one of our chief science advisors for our board of directors and has had a very large part of gaining acceptance into not only the Port of San Diego, but a couple of the other pilot locations that we're currently evaluating right now. Jump forward to 2017, you can see Serge Albino, which is our CEO, sitting on the right-hand side, and Ian Dormal, who is our executive vice president, signing the exclusive license for our Spears technology. We signed the exclusive license at the very end of 2017 and officially kicked off Ecospheres in 2018 and began to talk about the technology and see where it could be applicable. And that's really where we ran into the Port of San Diego with Jason and Philippe and Paula over there. So how do we really do environmental remediation while ushering in that net zero future? We utilize a different method than a traditional approach. We actually take and we have a two-phase approach of extraction to elimination here. So the technology that we are working with the Port of San Diego right now is the Ecospheres technology. This is an in-situ sediment remediation technology that you deploy down into the bottom sediment layer, and it passively absorbs contaminants like a sponge. Once we get down to a point where your bulk sediment is actually below what is deemed clean from federal EPA or whatever our client is specifically asking us to, we can remove the spears and we'll bring the toxins out without removing the actual sediment from the environment itself. At that point, we'll go through an elimination stage, which is our EcoCube on the right-hand side here. Our EcoCube is a UV elimination treatment system that actually goes through a dechlorination of the PCBs. So instead of just bringing them to a landfill and hoping that they don't leach back into the environment, we're going to destroy all the chemicals that we can on site and bring them all the way down to non-hazardous benign byproducts. So there is no chance of recontamination back into the industry. So to kind of give you guys an idea of what spears really do and how they work, since everything that comes out of NASA has to have an acronym, so do the spears. So our SPEARS stands for Sorbent Polymer Extraction and Remediation System. And it's a fancy term for saying that they're 12 or 18-inch spikes that we put a alcohol reagent on the inside of. The picture on the left here is actually the one that we did with the Port of San Diego, and that was a really key piece for us as a company and for the technology, as it was our first in-field live application of the technologies for impacted sediments. What was kind of interesting with the Port of San Diego is they had a endangered eelgrass species, which I'm sure a lot of the ports around have, species that have really sensitivities for some of the methods that they have for cleanup. And in utilizing our spears, we're able to go around where we've seen the eelgrass in the past and continue to do a passive remediation kind of surrounding that sensitive environment. So we're not actually destroying and having to repopulate or replant that species elsewhere throughout the port. One other important thing that we had with the Port of San Diego over there is an economic incentive for the port. With most current methods, if you're talking about doing remediation in the port, you're either talking about dredging or capping, which can shut down the port for an extended period of time to do that same remediation for the impacted sediments. What our spears has allowed us to do is work hand in hand with the Port of San Diego in busy port slips like what you see here to deploy our spears down into the bottom sediments and then move the boat off site, and you'll get a passive remediation over for what we're doing with the Port of San Diego is going to be an evaluation of 24 months for the absorptive, to see the absorption rates of the spears themselves for low-level PCBs within the port. And that was a really big driver for us, is we didn't truly understand the impact that the spears could have until we started to work hand in hand with Paula and Philippe to understand that the spears not only protect the environment, but they're also helping us protect some of the economics of the local communities as well. And that's where we started to really try to branch out from this initial deployment of low-level PCBs and really deep sediments for what we're considering deep, between 15 to 20 feet. And we also signed a pilot with the Swedish University of Umeå University over there in Sweden. And this really challenged us from, we knew we could deploy our spears in a strategic area from what we've learned with the Port of San Diego. And now it's a matter of, okay, can we do it in an area where it's not common and kind of familiar to us? So we picked a fiber bank that was also an old paper mill. And like what you see here is, instead of having your endangered eelgrass, here we're actually deploying around logs, and we're going after impacted dioxins rather than just the PCBs and the PAHs that we have with the Port of San Diego. So we had a lot of lessons learned from the Port of San Diego that really helped us out with, like, Umeå University, and in kind of thinking about, okay, now we are branching out from PCBs to dioxins and PAHs. What happens if we're now looking at more upstream areas, like in a tidally influenced wetland area? And this is what we're actually working now for a client on the Anacostia River. This is a PCB area that it is more of an upland setting. So the tide comes in and it's roughly underwater for about 7 hours. The tide leaves and it is a walkable wetland area. So in looking at how we can help more of the ports in these coastline communities, we're now able to walk out to these wetlands and do just a down pressing of the spears themselves without the use of boats altogether. And what we're really targeting is trying to hit the PCBs before they make their way into these deeper sediments that could potentially be washed out to the ocean altogether. Think about in this area, it's more of we're creating a curtain of spears where as the pore water is moving in and out of that bulk sediment area, we're going to try to absorb those chemicals before it makes their way into the river and then out to the sea down below.
You have about a minute left, Trevor.
Awesome, Matt.
Thank you.
Perfect timing, because this is
Right.
actually the end of the presentation here. And like kind of previously said, I'd love to take any questions. And if you guys have any impacted sites that you're looking at that some of the current methods may not be adequate for, this technology could be a potential game changer for that area as we look at the remediation as a not black and white like what the current regulations are, but more how can we adapt to your specific scenario. So I appreciate the time and I appreciate you guys asking Ecospheres to be a part of the panel. So thank you very much. Again, my name is Trevor Ludwig from Ecospheres.
Thank you, Trevor. That's really wonderful, like hearing so much about how your technology is being applied elsewhere since the port. So we really appreciate that. Looking forward to questions in the chat later. Next up is Maor Besner from Econcrete. He's the Chief Technology Officer there. And we're looking forward to hearing from you, Maor.
Thank you very much. I'll start with saying thank you for BlueTech TMA and also the Port of San Diego for graciously hosting this very important webinar and for giving us a chance to speak in it. As Paula said, I'm representing Econcrete, and at Econcrete we make biologically enhanced marine concrete infrastructure. Which is a very long sentence. I'll explain what it means in a second, but I'll try also to walk you through how it started, what it is, how we got to a stage that we are now operating in a much bigger scale, and to show a collaboration that we did with the Port of San Diego through the Blue Incubator that was mentioned before. Again, a chance to say thank you for the Port of San Diego and this amazing program that brought great progress, not only to us, but also to the environment. So how did it start? Basically, it started with these two crazy marine biologists, Dr. Ido Sela, and the late Dr. Shimrit Perkol-Finkel, who we lost last year. Now, these two truly love the ocean. There isn't a spot in the world they didn't dive or do some research in or just have fun. And the more they were doing it, the more they realized that there's a lot of concrete marine infrastructure. Now, when I say a lot, 70% of it is of the marine infrastructure is out of concrete. And concrete is not a very good, let's call it, not a very good ecosystems for the natural habitats of these waters. It's not such a good habitat because of the byproducts of mass production and because of its material composition, which tragically enough make it the best material for marine construction. However, being the scientists that they are, they have developed a 3-pillar design system, which is comprised of the admix that deals with the material composition, and 2 other layers of micro and macro design to facilitate the growth of marine or biological species in the marine environment. Now, what you're seeing here is a block that is designed with these 3 pillars, and a very similar block that you're seeing now was placed in Haifa almost 8 years ago. Now, what you can see here is a piece of constructional grade concrete complies with all the marine construction standards all over the world, but it's also a thriving habitat to sessile communities and algae and vertebrates and sessile invertebrates, which are very, very fancy words for seashells and sea fish and algae. What these creatures do in return, they filter the water, they clean it. That's what they do. That's how they survive. Not only that, they actively sink the carbon from the water and attach it to the concrete, thus creating a stronger, more lasting infrastructure. Now, the admixture will enhance the concrete strength by about 10%, thus reducing its sensitivity to erosion and corrosion, and preventing chloride penetration, which is a very big pain if you're building a port. We're not going to touch that today. And the most positive side effect of this 3 pillars of design and this admix is that you have a live layer of calcium carbonate, which again is a very fancy word for seashells, that protect your infrastructure, thus creating it longer, more resilient, more lasting, and making it more cost effective. Now, it's more cost effective not only because it's longer, more healthy, and more effective. And we're talking about 120 years mixed design. Yes, that's very, very long. But again, we're not in the marine construction presentation today. It can and will also help in permitting. But how the hell did they come up with this idea? So they were walking around and they saw that in urban infrastructure, there is sort of a solution to bring nature into the city or to help to co-live hand in hand. However, as you can see here on the bottom right, the more they dove and saw this marine concrete infrastructure, the less thriving ecosystems they saw. Having said that, at the same time, there is a trend of biodesign that was appealing at that time. I think it's around 2012, the Sydney seawall and the Seattle waterfront 2015, which is an amazing, amazing, amazing landscape project, and I recommend everyone to check it out. And they were having very pleasing results with some of the things. However, the concrete itself, as you can see here on the left, was still very, let's call it dry or not bio-recruiting. The whole design of the project was a great success, by the way, but the concrete itself had very limited results. As you can see, a couple of other projects worldwide at the same time. So they understood it has to be not only the design, the macro design, it has to be somewhere with the micro and the material. Thus, they came up with this 3-pillar solution. A, the material, as I said, to even out its harmful impact on the environment. And the more crucial of the parts of the design is the 2 layers of micro and macro design to facilitate the attachment of young larvae, of young baby species, and then to make a bigger home once they grow so they can stay attached to this infrastructure. So being the scientists that they were, they straight away went into validating it and very long experiments in 7C. And of course, I think I'm not going to step all the way into it, but in order to verify that indeed you have something that works, not only in one single place that you place it, there was a need to create a huge variety of data from different environments, as you can see, Red Sea, Mediterranean Sea, Atlantic. We'll see at the end the Pacific Ocean in San Diego, and even the Great Lakes. And the more they did the test, the bigger and bigger the database became, and the results were pretty inherent. If you combine, sorry for repeating this for the who knows what time, material and 2 layers of complexity, what you get, as you can see here on the left top corner, is a living piece of concrete that is better not only for the environment, but for the construction it's going to build. So we were amazed with the results. We didn't believe we would get such things. And these kept on coming both from lab tests and from the Red Sea. And at that point, I think it's 2012, there was a need to test it on a full scale. Luckily, they managed to get a pilot in with a full-blown anti-fail that was a breakwater that was built outside of Haifa. And I don't know if any of you or the participants know Haifa, but I assure you, not the highest quality water. But they were managed to put same size blocks as the breakwater, just with these 3 pillars of design, and to monitor them over the course of 3 years. And lo and behold, the results were outstanding. You can see here in all the tests, the invasive to non-invasive species, the sessile communities, the clams, the water quality, and the concrete quality all improved tenfold. At this point, okay, so we had a local pilot in Israel. Now it's time to expand. And where better than Brooklyn and New York? There was a need in the city of Brooklyn to, oh, my presentation seems to be stuck. Oh, there we go. But there was a need to reinforce these pile jackets. Now, traditionally, this is done with one-time molds that get stuck there. Sometimes they're from plastic, sometimes they're from fiberglass. However, by implementing these 3 pillars of design, again, you can see the results here on my right. There is no way to argue about it. There's a control jacket and there is an ecological enhanced one. But at this point, we were lucky enough to get a grant from the Bird Foundation, which is an Israeli-American foundation for bionational and industrial research and development, and to team up with an amazing partner called Besser. They're the lead producer of mass production concrete factories in the US. And we were able to develop a product that is, again, in high demand in the concrete infrastructure market, which is an articulated concrete mattress. And what you can see here is the results. And now I'm sorry for going a bit fast because I want to have time also to touch the project that we did in San Diego. The next step that we had was getting into the specification of this amazing project, the Living Breakwaters project. And this is a huge project. These are 7 breakwaters that are built outside of Jersey City, of Staten Island, sorry. And they are all implying not only these 3 pillars of design, they're also implying other very progressive bioenhancing designs on the full scale designed by Escape, which again is an amazing partner if you're doing projects of this magnitude. Now let's talk about San Diego and the Blue Incubator. Luckily, we had a chance to cooperate here, and then again, big shout out to all the team that we were lucky enough to work with. The Port of San Diego wanted to look into a replacement for the riprap preventment. And we wanted to introduce into the market a single layer interlocking concrete armor system. That is also a thriving habitat for marine species. And luckily enough, we had the chance to do it together. Mind you, throughout COVID, it wasn't very easy, not only on the technical side, but we couldn't make it to San Diego. So that was even more challenging, but we managed to go through it. And here you see the installation in March 21. Now, what's interesting about these units is the fact that, as I said, they're single layer interlocking concrete units that are biologically enhanced. But because they are single layer and interlocking, you can use less concrete, less material to get greater shoreline stability. Therefore, you are saving in the amount of material and emissions you're putting along the shoreline. And because it's also bioenhanced, these units, as you can see, they have a very unique shape. So if you shape them in one way, as you see here in the bottom, they are caves. Although if they are slightly oriented in a different direction, they act as water retaining elements. So this is the finalization of the installation in March 21. On the monitoring we had in August 21, 5 months later, we were amazed with the results. What you can see here is an immense amount of, again, I can say the Latin names, but I think it's not the point. I think the point is their variety. What you see here is concrete that is thriving habitat and is protected by that habitat and enhancing that habitat at the same time. At a later monitoring, 3 months after that, sorry, not, yeah, three months after that, we were able to see even bigger marine species, like you see this humongous marine hare or Aphalasia californica in the Latin name, that it's natural habitat and it hasn't been seen in that area for a long time. And the reason is that simply that riprap does not have water retaining elements, and this species needs a pool that fills up during high tide and stays there during low tide to lay her eggs. And this mother was there laying her or taking care of her offspring, and we were very, very happy to see it. Now, this pink algae you see here is also a very, very interesting creature, and the reason is so interesting is what it does to survive. It actively sinks carbon from the water, takes it apart, releases the oxygen, and sinks the carbon into the concrete, protecting the concrete and giving the Port of San Diego resilient concrete infrastructure with a positive carbon sink, which is, I think, is a truly unique matter, no matter how you look at it. So I hope that wasn't too much information in too little time, and that you had a good time. And thank you very much for having me.
Wow, Maur, that was really wonderful. Great background and good focus on our project at the port. So I just wanted to get into the Q&A and maybe just have a quick comment. Super grateful for all of you speaking about the port, specifically working with myself or Philippe LeBlanc, our former program manager of the Incubator and now consultant for us, and also Jason, our vice president of environment and planning. It's not just us that projects interact with, right? So part of our core value proposition is really, a port-wide collaboration. So we have lots of different departments in the Port of San Diego, lots of different subject matter experts that are working with our companies, from permitting and entitlements for their projects to evaluating, any type of environmental remediation or services that through our environmental protection departments. The e-concrete project worked heavily with our engineering departments and local contractors. So we just want to give out a shout to it's not just us on our team, it's like a lot of different departments and contractors that operate in the port. So thank you. I'll ask a general question to all of you, and then we'll get into the specific questions in the chat. But I guess overall, what challenges do you face regarding adoption of your technologies, right? And in relation to this question, what would be the main barriers that the port helped you overcome for each of your projects? So I'm going to start in the order that we went, and I'll just hand it over to you, Emily.
Yeah, so I would say for us, a big barrier is just there's a high, clients want to see kind of a high burden of proof that, the technology really works. We've demonstrated it in many different types of water, many different settings. And so it's been really great working with the port, just because it's we're able to, develop this and pilot this in a real world setting, and we're able to do it in an iterative way that's not just, okay, we test it once, did it work? Yes or no, but rather we're able to, do a lot of testing over a period of time and really make sure that this is going to, perform the way we expect it to. Because, with sensor technology, you always worry about interferences, things you've never seen before when you look at different samples. So I'd say that's just been really great for us. And we're really looking forward to some of the case study data we're going to be able to put together on, the project once we start to get the units in the field and collect some of that data.
Super cool. All right, how about you, Trevor?
Yeah, like Emily said, the burden of proof is always really high for these new technologies to be able to get into the regulations. And what makes us a little bit more different than like a traditional remediation is there is no regulations kind of put forth for an in situ passive remediation technology like this. So to get a regulator to approve, to say, yes, that this is something that we can do, and to have a client say, we will be willing to be the first, that was a big thing that the Port of San Diego helped us with. Was you guys allowed us to go in and work with the Army Corps of Engineers and implement this technology to kind of gain that that precedent that this isn't something that is going to be harmful to the environment. And that's kind of allowed us now to be able to say, okay, this is what we've done with the Port of San Diego. Here's how we permitted it with the U.S. Army Corps before. Now this is something that we're going to be able to do elsewhere because we have kind of that precedent set at this point. So that was one of the big things for us that we looked for with you guys specifically for the that BlueTech accelerator.
Excellent. All right, Maur.
Yeah, I will just add on to Emily and Trevor and say that a lot of the time the hardest thing is getting that first leg through the door. And fortunately enough, you guys were forward thinking, and you were brave enough to take a shot on a blue technology that wasn't there before. Though all the science and the engineers say, okay, it's working, no one, especially in the marine construction market, doesn't like to be the first. They want to be the second if it facilitates permitting and helps with mitigation even better, but please try it out first somewhere else, not on my watch. And I think the results speak for themselves because it positions everyone in a different place, both ourselves and the port. And I think just as a proof of that, there's going to be 2 full-scale installations of this product, hopefully by the end of this year. And this has a lot to do with I'm calling it a risk, but it's not a risk. It's being the first that you were I don't know what the exact word is, but you were. So yeah, that's how it helped us.
Well, that's fantastic. Thank you, everybody. I think we'll just switch over to questions from the audience, and I'll start again, but then I'll change up the order after this round. But Emily, first question for you was, are there any other plastics or plasticizers other than PFAS that you're exploring?
Yeah, that's a great question. At this point, we're pretty focused on kind of PFAS compounds, so I'm not sure we've explored too much in terms of other plasticizers. But that's not to say it's not possible. I'm guessing that if we can develop something for PFAS, it'd be pretty similar for some of these other compounds. So I think that's definitely something in our wheelhouse, just not something we have had on the radar up to this moment. But that's a great comment.
Excellent. Okay, Trevor, this one's for you from Dave Marchetti. What's the max water depth for which your product is rated?
Yeah, so currently, right now we have pilot deployments for up to 20 feet down below the surface water. And one of the challenging pieces for us was if you are deploying off of a boat, like what you saw with the Port of San Diego or Sweden, you have the top tide is actually pushing the boat. So trying to get a spear that goes straight down is challenging for us. So we're thinking about 20 feet if you have to deploy off of a boat. However, our engineering team has developed a gantry system that we can actually go, and it is a stationary kind of deployment mechanism that is anchored into the sediment layer. So there is no top movement. So at this point now we are actually trying to see what depth we can get down to with that sort of stationary deployment mechanism now. But if you are looking at more of a boat like what we had to do with the Port of San Diego because of the active slip working in there, you're looking about 20 to 25 feet.
Great question, great answer. Okay, to you, Maur, from Society of Maritime Industries. How does your products reduce invasive species?
Well, that's a great question. So basically, wherever you're going to put something in the water, there is going to be a certain amount of growth on it, okay? However, invasive species, what they are, they have a natural, or not natural, they have an advantage over the non-invasive species. Therefore, they are stronger, faster adapters like us humans, and we all know how that's working out. But what we do is we even out the chances for all the species in that area to latch on. Therefore, if an invasive species usually attaches easier to the riprap, it will take up literally all the real estate there is for the other creatures to latch onto or to grow with, thus creating a desert, and he has a monopoly over that real estate. But our design, because it's designed to enhance not only one strong species, but all the local species as well, evens out that monopoly. Does that make sense?
I think so. And while we're let's see, while we're still on you, Maur, let's have another question from Manuana or Manuha. Sorry if I pronounced your name wrong. How do you achieve the low carbon aspect? And are you do you partially substitute cement with any other material? And have you guys looked at industrial waste as partial substitutions?
So I will divide this into three. Regarding the last one, the admixture that we add to the concrete is made out of 99.9 industry byproducts. That's the admix we put in. Now we have no objections to using byproducts if they are with line with the mix design, because we usually use the local mix design. So therefore, if the local contractor would like to use recycled aggregates, we would highly suggest that. And regarding the low carbon, I'm going to split this one into two as well. So the mixes that we suggest have a less cement, or it's not correct to say that they have less cement. It's because they are a high-performing slag cement base. They will have less cementitious material, therefore less carbon footprint. And the second part of the answer is that we don't make the carbon lower. What we do is we promote growth of sessile communities of calcifying organisms. These organisms actively take carbon and sink it to the concrete, thus creating a lower impact of carbon on the long haul, but not especially in the production process.
Very good answer. Thank you for that. That was a big question. Okay, switching back to Emily. Next question from David Ford. Is your product of value to aquaculture, say water quality in shrimp ponds, as an example?
Yeah, that's a great question. I'm not totally sure about shrimp ponds. It would depend a little bit on what parameters, were needed to monitor. I think definitely in terms of, could we measure things in that matrix? Absolutely. So yeah, I'm not super familiar with some of the issues in terms of what, water quality parameters would be of most value, but I definitely love to chat more about that. And I think there could definitely be some application there.
Okay, back to you, Maur. So let's see. Question from Hamal. Have you considered injecting captured carbon dioxide from, say, tailpipe emissions or from industrial sources into the concrete?
Well, it's a great question. We're not concrete manufacturers, as I said. If the the local concrete manufacturer will be willing to do so and doesn't compromise the structural integrity of the concrete or the biological performance, we would have no objection to it. But it's very important for me to emphasize that we're a unique company in that way, because generally we wouldn't want people to use concrete. Okay, and but if you are going to use concrete in the water, please do it responsibly. So in that way, we do not promote the selling of concrete. However, if someone is using concrete to build an infrastructure, we would happily help him do it responsibly.
Okay, great question, great answer. Next question in the chat is actually back to you, Emily. Can your system measure ocean pH levels within kelp forests compared to non-kelp forest pH?
Yeah, I believe it could. I don't see why. I again haven't done any specific testing in kelp forests, but I imagine it would work in that atmosphere. Absolutely.
Okay. Wow. Thank you, everybody. These questions are pouring in. Next one is back to you, Maur. From Nick Herring. Has eConcrete experienced any supply chain related challenges, i.e. getting enough materials while scaling up these past few years? And how do you supply the concrete around the world? You might have answered this in the past question,
Yeah.
but go for it.
So yes, of course, we are experiencing some issues, especially on, as you were right to say, on shipping things. However, we never ship the concrete. Concrete is the marine concrete, marine infrastructure concrete will generally be produced not very far from where it's placed or exactly where it's supposed to be, if it's cast on site or precast on site or precast not a lot further from on site, because shipping concrete is, it's not a good idea, not for the environment and not for your pocket. But we do supply a technology, and this technology we're working ever more to manufacture it more and more locally and reduce shipping to a minimum.
Excellent. All right. Back to Emily. Can you, from Patrick Corsels, can you speak a little more about the work FriendSense is doing with PFOS and PFAS, and how close are you to commercializing a solution?
Yeah, so we're working with a partner organization on that, and so we have some really promising early data on that. We are expecting to have it in doing some field pilot testing by the end of this year. So we would expect this to be commercialized likely in early 2023 is the goal right now. But we're openly looking for pilot partners. We have a few sites kind of secured for doing some of these testing, but would love to chat to more people that have PFAS related problems and might have test sites for us.
Super. Okay, potentially last one for Maor, from Rob Hale, who's building biodiversity and carbon modeling and monitoring tools and about to enter the marine environment. Could you share data from your installation so that we could model possible interventions using e-concrete? Is that something e-concrete would do with other companies?
Yes, definitely. We would be very happy. We publicize our monitoring and we have a specific intention for that. If you would want specific information, please feel free to contact me after the webinar. And I'm going to take the chance because I saw someone wrote a question about the typical price per square meter, which is the king of all questions. And I was surprised no one else has asked it. So, of course, if you're comparing dollar to dollar, making biologically enhanced concrete is a bit more expensive, not a lot, mind you. However, the amount of money that you're saving on a more resilient infrastructure, and I'm not even talking about if there's mitigation in the area you're building, I'm just talking about more resilient, healthy infrastructure is immense on the grand total of the project. And now I said that because in some of the cases that I've shown in the presentation on the full-scale projects, our intervention inside the project has reduced the overall pricing cost of the project by a couple of percentages. Okay, so that's a very, very big advantage. So the price on the square meter, of course, is a bit higher. However, it's not gray concrete. This is blue concrete. When the iPhone came out, a Nokia used to cost what, $100, $50, and an iPhone how much? It's just not the same thing. It is strong and constructive. It's just not the same thing.
Fantastic. So I'm just going to do a couple more questions from the chat and then pop back to some general questions for all of you. But from Chris Ward to Emily, do you envision your technology ever being able to be used as part of an online process, i.e. in real-time control?
Yeah, that's absolutely what we envision. So right now it's very much, a grab sample model where you take a sample and, plug it in terms of this solution, or, on our biosensor platform, you inject a water sample in. But in the future, we absolutely would hope to get, an online version of this that's capable of, taking some of these measurements on a routine basis. And that's kind of been some of the exciting work we've done on this project, is really refining some of the liquid handling systems that we think are going to allow us to get to that stage in the future.
Fabulous. I'll throw another one to you from Nick Herring. Do you envision testing equipment that couples the microbial and colorimetric sensors, or will you offer separate units?
Yeah, that's a good question. Honestly, still something we're mulling over. At this point, they're separate units, but I think it would just depend on kind of the pairings of the analytes that can be detected with each. And if those, made sense to have in one unit, I think there's absolutely potential to do that. And that would be our preference, because we're really focused on creating a platform where you can test, a bunch of different analytes. And the goal would be to not require, all sorts of separate equipment to be able to achieve that.
Okay, not to overwhelm you, Emily, but the last two questions in the chat are for you. from Cleaner Ocean Foundation. What are the plastic and clothing fiber levels? Can your system cope with such data acquisition?
To be perfectly honest, I have no idea what clothing and fiber levels would look like. That's not, it's not something we measure today. Haven't identified that as being an issue for our measurement systems in terms of an interference. But to be perfectly honest, I'm not super familiar with exactly what those levels would look like. And definitely, I'm sure measuring those kind of parameters could be really interesting. Probably not a good fit for what we're doing, and imagine more of a physical sensor would probably be a better fit there. But definitely a huge challenge.
Okay. And last question for you and in the chat. Is FredSense aware of the pollution issues at the Imperial Beach, Mexico border? If so, would your technology be able to be used there?
No, I'm not personally super familiar with that. So again, we'd have to look at kind of what analytes would, be important to measure in terms of the quality there, but definitely that could be an application. That's something we can look into.
Excellent. All right, well, let's just switch back to some general questions. I'd like to, just ask all of you, what's next for your companies and exciting for all of your companies in the pipeline. So I'm going to start with Trevor.
Yeah. So for Ecospheres, we are looking at doing more larger scale pilots for our Spheres technologies. We're working with Sweden right now on a potentially 1,000 square foot deployment that we can do over there with them. But we're also not pivoting, but we are looking at evaluating our soil washing technology. So the other extraction technique that we have utilizes that same interior reagent that we have in the Spheres, but instead of a passive remediation, we're looking at doing a soil washing, which is almost an instant desorption of the chemicals from soils or dewatered sediments. And we are commercializing that at a full scale application with the US Coast Guard right now over in Guam. So we should have that in place by the end of the year, as well as now evaluating some technologies for the extraction and elimination of PFAS without using temperatures or pressures. So there's a lot happening on the environmental side. And for everybody that knows about the environment, a lot of people know PFAS is a big emerging contaminant that everybody is trying to look at right now. So that's definitely one of the exciting things for us over here, is figuring out how our technology could be potentially applied in the more remote locations like Guam, Hawaii, Alaska, and then over in Europe where they don't have a lot of other options.
Okay, how about you, Maor? I think you touched on it in your presentation, but it'd be great to hear it again.
Yeah, we're growing and commercializing. Obviously, we're looking forward to a couple of full-scale deployments in Europe, in the port of Vigo that we're building right now. It's by the end of the summer, I hope it will be, and in a couple of other ports in the Mediterranean. We are we made our first cornerstone in the offshore market, which is a very big step for us. It's going to be a huge environmental impact in the coming decades, and we want to make sure that it's done properly. And also expanding in the east, so having a our first full scale there. So very exciting time.
Sure is. It's a lot of work. Okay, how about you, Emily?
Yeah, we're quite excited about some stuff we have upcoming. I would say definitely the work we're doing with the PFAS sensor work is really exciting for us, and we're hoping to see some good stuff by the end of the year. We also have some larger scale arsenic deployments coming up, which has been really exciting for us, because that's been a challenging, the utility market's been a challenge during COVID for sure. So it's nice to see things kind of stabilizing there. But I would say the work that we're doing with the port, we're really still in the, the heart of that, that project. So we're really excited about what we're going to see in the next year, as we kind of move further in that project and wrap up some of the testing that we're doing. So we're really excited to kind of get that, get units in the field and get some of that stuff, start seeing some of the data from that.
Yes, definitely agree with you on that. Okay, question from the audience for all panelists, from Jamal Black, are any of your technologies available for carbon offsets? I'll start with Trevor, back to you.
So currently we've been trying to work and figure out how we can provide carbon offsets. Right now, we don't have anything, but with how the spears technology works, if we can show remediation of the spears, we're trying to figure out a way that we can give carbon offsets by the aspect of, if you were to do it like a dredging operation, we're able to save X amount of carbon emissions through our process this way. But that's still something that we are actively working on. We're actually working with the EPA Smart Ways here to do a general calculation of how much CO2 our process would save if you utilize like dredging to do the same area that we're doing, but that's still something in the works as of right now.
Super. Down to you, Mauer.
Yes, we definitely have a way of quantifying the carbon offset that we do offer. However, I wouldn't go as far as say that we can already give these carbon offsets, because this, especially in the marine environment, it's still a process. It's not only a process in Europe, also in the US. It's a process of how you measure it and who is alleged to give it and to buy it. So yes, we have the data. Once let's call it the decision makers will finalize the guidelines, we will hopefully be able to give it as well.
Yeah, that is definitely true. As carbon or blue carbon crediting accounting gets a little bit more advanced in the marine environment, I think there's not just your technologies, but there'll be a lot of opportunity for folks. Emily, I didn't give you a chance to answer that question. I'm sorry.
That's all right. I can keep it short. We currently don't have that available, and it's not kind of in the immediate roadmap, but definitely something in the future to look for.
All right, well, let's see. We have a few minutes left. We have one more question from the audience for all the panelists. Do you have a plan to offer your products in South America? Go to you, Emily, first on my screen.
At this moment, not very advanced. We haven't done a lot of exploration in the South American market, but having said that, I think that's definitely somewhere that would be of interest to us. So we'd love to have some more conversations on what current challenges look like, and if there's any specific kind of regional challenges you might see, that would be really helpful for us.
Wonderful. Trevor?
Yeah, so the South America market actually is one of the ones that we are currently looking at right now to be able to deploy our technologies down there. We actually work pretty closely with the United Nations, and the majority of our technologies are actually written into the Stockholm Convention as an alternative for incineration for PCBs and dioxin destruction. So it's one of those things where we haven't done it in the past, just because we're trying to find the right partners to be able to mobilize down there and work with in that South American market. So we definitely will offer the technologies. We just need to identify the correct site and the partners that we need to work with that kind of know the local governments and regulations for these types of chemicals.
Wonderful.
Definitely, it's available globally. There are some things that might happen, but very, very early stages. So I don't know who asked the question, because if you are interested, we can make it happen.
That's excellent. Well, I think that's I'm not sure, Matt or Danielle, if there's anything to close out from your side to keep us on time, but I just want to say thank you. All three of you have been fantastic partners in our portfolio, amongst many others, and we're super grateful for you presenting today. And if I missed any questions, I apologize in the chat. I know all of us are available online after this, and I believe Danielle and Matt can speak to this. I think this will be posted elsewhere, but I'll hand it over to you, Matt. Thank you, everybody.
Perfect. Yeah, thank you so much to everyone who was on this panel. It was fantastic and really fascinating to listen to. So, and Paula, thank you for doing such a great job of keeping us on topic and for answering the questions. And of course, Emily and Trevor and Mara, thank you so much for being a part of this, and keep us apprised of your progress. I just wanted to close out by saying that our next BlueTech Global Connect will be on July 21st, and it will be Seafood for the Future, supporting industry and conservation. We will have 3 companies attending, and they will be Hicks Blue from France, OLSPS from South Africa, and Blue Nalu right here in San Diego. So that's it for now. Thank you so much for everyone who attended. And again, we will post the video of this recording sometime early next week. So thank you very much. And yeah, have a great Thursday and the rest of your week. Cheers, everyone.
Thank you very much for having us. Bye-bye.
Thank you.
Yes, thank you guys. Appreciate it.